Okay. So Mr. Ting, so I'm doing this recording so that you can review this draft, um, this interim draft walkthrough at your own time. Um, Hopefully it is convenient. So I'll try to keep my sort of walkthrough as short as possible. So yeah, I'll start now by saying, um, so one thing that I've seen from the gravimetric standard for measuring the MVTR is that they do provide they do provide numbers for uh, the recommended amount of days for your test duration to run, depending on what balance resolution that you can achieve with the equipments that you have. So for me personally, I'll probably be running the entire test for 7 days, just so that my the equipment that I'm planning to buy, which is really just a load cell and a voltage amplifier, to really um, to really capitalize on the sensitivity of the load cell. With these two things, I should be able to reach the milligram range. So by setting my expectations to this 10 milligram range and running it for 7 days, I should be expecting decent values. Of course, after I calibrate the weight with uh, with uh, the known weights that you can buy from online as well. Okay, so yep, that's just for the electronics itself. I will be running a Raspberry Pi for as a microcontroller and recording the the entire mass change throughout the experiment, in conjunction with also temperature sensor and the humidity from a BME 280 module. Okay, so there's really not much to say here, and here's roughly how the diagram looks, how the sort of uh, suggested setup that ASTM has come up with. I'll strictly be going with the water method. So the water in the test itself, the water through the water method, the water itself would be trying to get out of the container. Okay, so I'm using water because it's simple and I can get it easily. Yep. So that's all for the standard itself. I can now show you how the setup that I've come up with. Now I'm running 4 containers with each of them being able to house 100 grams of water inside of them. So how I will be uh, making sure that I really add in 100 grams of water all or most of the time is by using a syringe. So yeah, that's pretty much it. I'll probably get it from Guardian, from the Clementi Mall. So they do sell syringes there at their pharmacy. So I'll just get it from there. Now get the receipt for you to do the claims. So yeah, 4 of them. The exposed area, surface area for the test barrier here, um, will be a total of around this amount. It definitely doesn't really mean anything, but why I'm using 4 is so that I get a larger mass change when I get all these, because I'll be taking all 4 of these masses as one single input to the load cell. And it will definitely act as a sort of average over 4. My understanding is that it would help sort of to lower down the tolerance requirements on the balance resolution as well, with if I do run when I do run 4 of them together, because the sensor should be expected to see a larger mass change after the end of the entire test duration. Now, the frame itself to for all 4 of these containers to mount onto would be aluminum extrusions, as you can see there. The spacers here will most likely be printed out of glass-filled ABS for the stiffness. And yeah, so all these would any of the joints would be metal. So as you can see here, I am actually using bearings. The bearings here only do one job, which is to constrain the movement of the entire frame itself only in the vertical motion. Okay, it's not really showing. Okay, yep. So as you can see here, it should only constrain my entire setup in the vertical motion. Yeah, it's quite laggy, but I hope this does help you sort of understand the thinking behind the use of the bearings. And I'm using 3 instead of 4 because 3 constraint points define a plane. And yep, that pretty much is my explanation for that. That's my justification for that design choice. And for me to transfer the total load onto the load cell down here, I am using another rod that will be bolted onto this intermediate plate right here, this green one. And yeah, that is how I'll be transmitting the load from all 4 of these onto the load cell. The load cell itself, there's a few ways to mount it. One way is to adhere it with some form of double-sided adhesive, or I can find a way to clamp it from the top onto the rim right here. These are all from the data sheets, as you can see from this page right here. Yeah. So yeah, there are 2 ways for me to mount, then I'll have to figure it out on this part after my exams. So that's it for that's the gist of the setup overall. Now what I'm definitely missing here that you're not seeing is a sealed sort of environment. So I'll also be constructing that sealed environment with aluminum extrusions that are already available at T14. I'll be covering it up with maybe some acrylic or polycarbonate sheets, and maybe I'll seal the gaps with some form of silicone if I really do feel the need to do that. And to promote sort of airflow in and out of the seal environment, I'll be adding in some fans to intake the air, and also to intake the air, blow over the mouth of the containers, and have exhaust fans at the other side to draw all that air out. I'll be putting the BME module that measures the atmospheric temperature, the environment temperature, and barometric pressure, either within the chamber itself, within the sealed chamber itself, or right after the intake fans. It's inconclusive yet, but it's somewhere there. And yeah, so this the wires would go out of the sealed chamber. There's going to be something done there, but yeah, I'll somehow seal it off as well. So I might be buying some cables or something for that. Okay, so diving deeper into the container itself and how it's constructed. Now, whatever you're seeing down here, this is just for me to use when I'm doing the milling of the containers. So this doesn't really have any functionality for the test itself. The main functionality for the test that I've designed in is the grooves for the O-rings, to make sure that I really have an airtight sort of seal between the top and bottom halves, and I will be using 6 and 5 bolts for the for really ensuring that to apply that pressure onto the O-rings. And here's the test barrier, which will be printed at it will be a single layer of polypropylene at 0.12 millimeters. Why I am printing it that thinly is because I really want to make sure that there is as much mass change as possible, because from the numbers I've crunched and everything, as you will see from this website, this is a paper prepared for the Homeland Security by this national laboratory in the US, which they are talking also about water vapor permeation and plastics. Apparently from their research, they are saying that polypropylene is expected to have 7.8 to 91 grams millimeter per meter squared per day of water vapor passing through the test barrier. Now, that number does seem like quite a bit, but then you have to understand that the surface area that they are using is per meter squared, and the maximum size of my component is not close to the meter. So I wouldn't be expecting changes in the grams. I'll actually be expecting changes in hopefully in the tens of milligrams and not in the milligrams or sub-milligram ranges. Yep. And as for the container material choice, I'm choosing HDPE because according to their research and their literature, and also the literature of other sources like of other sources that I can share with you if you want to know. HDPE is is 1 or 2 magnitudes less water permeates less water through it than polypropylene itself. So that's why I'm choosing HDPE, and there is already a local HDPE supplier that I'm in contact with at the moment for getting prices on the raw material itself. Okay, so that's it on the material choices, and some of the numbers on like roughly what I'm expecting to see when I set up the entire test itself. Alright, so yeah, O-rings, that's pretty much it. Then yeah, okay. If you have any questions on the test setup or other concerns that I did not surface up, or I missed out certain things that that you wanted to know, please reach out. And yeah, do review this video for as long as unfortunately I have exams in the following 2 weeks time, so whatever progress I'll be doing after this would be after my exams, which is roughly after the first week of May. Yep. So yeah, thank you for your time. And yeah. Oh, and before I end off this video, I do need I guess your suggestion on how I should be procuring the components. Okay, I'll show you the load cells first. You will see that I am planning to get 2 load cells, but it's not because I expect one of them to fail, but it's more on the situation where Mauser provides free shipping for most orders, for orders over $60, because the shipping itself, if I only buy one, is really $24. So I might as well buy another one already at that point, right? Now for the AliExpress side of things, that it is a lot more money. In fact, I just realized I need to buy a couple more things like the calibration weights. I